Scientists detect sign of something impossible out in deep space. The very concept of black holes seems improbable. Albert Einstein infamously refused to believe they could exist, even though his theory of general relativity was instrumental in predicting them. Now scientists have witnessed evidence of something about these baffling cosmic monstrosities that further stretches the boundaries of both physics and credulity. A titanic collision of two already enormous black holes, so utterly extreme that it has scientists wondering if the event they seem to have detected is even possible, as detailed in a new yet-to-be peer-reviewed paper by a consortium of physicists. The resulting black hole, whose signal has been designated GW231123, boasts an astonishing mass about 225 times that of our Sun Italy, making it the largest black hole merger ever detected. Previously, the record was held by a merger that formed a black hole of about 140 solar masses. Black holes this massive are forbidden through standard stellar evolution models. Mark Hannum, at the Laser Interferometer Gravitational Wave Observatory, which made the detection, said in a statement about the work, "This is the most massive black hole binary we've observed through gravitational waves, and it presents a real challenge to our understanding of black hole formation." LIGO, which consists of two observatories on opposite corners of the U.S., made history by making the first ever detection of these cosmic shocks. Black holes can produce huge, propagating ripples in space-time, called gravitational waves, which were predicted by Einstein back in 1916. Nearly 100 years later, the merger was first spotted in November 2023 in a gravitational wave, GW231123, that lasted just a fraction of a second, which results in the star being completely blown apart, leaving behind no remnant, not even a black hole. During the lead-up to the merger, the pairs circled around each other like fighters in a ring, before finally colliding to form one. Even so, it was enough to infer the properties of the original black holes. One had a mass, roughly 137 times the mass of the Sun, and the other was around 103 solar masses. These black holes are physically problematic because it's likely that one, if not both of them, fall into an upper mass gap, a stellar evolution. At such a size, it has predicted that the stars that formed them should have perished in an especially vicious type of explosion, both of which are equal to very significant fractions of the speed of light. Some astronomers argue that the mass gap is really a gap in our observations and not the cause of curious physics. Nonetheless, the idea is a hill at least some people were willing to get wounded on, if not necessarily die on. Cole Miller, of the University of Maryland, who was not involved in the research, told some, but perhaps the black holes weren't born from a single star, according to LIGO member Gregorio Carullo at the University of Birmingham. So tantalizingly, we're likely only scratching the surface of this mystery. It's an excellent case study for pushing forward the development of our theoretical tools. One possibility is that the two black holes in this binary formed through earlier mergers of smaller black holes, Hannum said in the statement. Equally extreme as their weight classes are, they're ludicrously fast. Spins with the larger spinning at 90% of its maximum possible speed, and the other at 80% in earthly terms. It's somewhere around 400,000 times our planet's rotation speed. According to the scientists, the black holes appear to be spinning very rapidly, near the limit allowed by Einstein's theory of general relativity. Charlie Hoy, a member of the LIGO scientific collaboration at the University of Portsmouth, said in the statement, "That makes the signal difficult to model and interpret." The researchers will present their findings at the GR Maldi meeting in Glasgow, which takes place this week. It will take years for the community to fully unravel this intricate signal pattern and all its implications.